Alright, so now that we've practiced expanding out, let's take something that is of this nature and contract it. So if first of all, I need to make sure I have all log base 4, log base 4, log base 4. They all have to be consistent or we can't expand and contract things, okay? So that's the first thing. If I have log base 4 of m, I'm going to put m on the top because it's my very first one. It's where I'm starting. Now I have minus log base 4 of an x. What does minus tell us to do? That it's going to be a quotient. So I put x on the bottom. And then plus z, so I know that z is multiplication, and so I put multiplication on the top. So these mean the same thing. Okay? We condensed the original, so let's practice with number 16 as well. The first thing I want you to look with, what do I do with this 3 that's out front? We make it into an exponent, just like we would take it from an exponent, move it to the front. Well, now we're doing the reverse order. So before I start, I'm going to move these numbers as exponents. So I would get log base a t to the third power minus log base a r to the sixth power. Well, I've taken care of the power rule and repositioned this exponent from a coefficient to an exponent. Now I want to condense it even further. Since this is subtraction, what will our logarithm be? A quotient, right? So I have log base a, and I would say t to the third divided by r to the sixth. Alright, this next section says use properties of logarithms. Assume that log base 10 of 4 is equal to some value. Okay, so this one they're going to tell us to use this. We can't necessarily use our calculator. In some future lessons, I'm going to teach you how to just calculate this in your calculator. But for now, they tell us to use this, find each logarithm. So log base 10 of 16, when I'm only given log base 10 of 4, my first thought is that I need it to be this so I can use this value. Well, I can't do anything. I don't have a 4 here. I have 16. But I could rewrite this as log base 10 4 to the second power, right? Because 4 squared is 16, and then that would give me my 4. But what do I need to do with this 2 then? If it's an exponent, I can use my properties to bring it out front. So that becomes 2 times log base 10 of 4. Well, that's nice because I know what this value is. It's that. So really all I need to do is calculate 2 times 0.6021. Put that in my calculator, multiply that out. I should get approximately 1.2042. So that's nice. Number 18, they say use this fact to be able to calculate log base 10 of 40. Well, I don't know what log base 10 of 40 is right now, and I haven't taught you how to do it in the calculator yet. So I need to use log base 10 of 4. Would you agree with me that I could rewrite log base 10, instead of 40, I could say 4 times 10? Okay, well then if it's multiplication, it can be rewritten using addition. So I would say log base 10 of 4 plus log base 10 of 10. This value I know because it's what they told me to use up here. So that becomes 0.6021. We learned that when this matches this, the answer is just the exponent. It's one of our properties and it's one of the examples. We'll actually continue to see this happen down here. And in light of what you learned in the very first part of the lesson, 10 raised to what power equals 10? Well, of course, 10 to the first power equals 10. So you will become very comfortable in noticing, recognizing when this matches this, the answer is whatever the exponent is. And the known exponent in this case is a 1. So then you would have 1.6021. So we can calculate log base 10 of 40 without a calculator using this method, using our properties. Alright, and then below, we just have a few more inverses and properties, some quick hits, some things you'll get familiar with. If you convert from logarithmic to exponential form, you can answer a lot of these or derive a lot of these yourselves, but if not, you will see. When you have a power up front, so this is, let me write it bigger, so it's 5 log base 5 of 8. So when you have a number raised to a logarithm and this matches this, the answer is 8. Okay? And these are like some special cases. When you have this matches this, the answer is the exponent. That's exactly what we just did on our last one. And let me make that one a little bit bigger as well. So log base 6 over 6, 2. When this matches this, the answer will be the exponent. Okay, so look at this next one. When x matches x, the answer is the exponent. So I will make that one larger as well. So when you start to recognize when this matches this, the answer is the exponent, then you would just say, oh, that equals m plus 5. It doesn't matter how ugly it gets. So a minute ago when we had log base 10 of 10, we said that simplified to 1 because when this matches this, the answer is the known exponent. In that case, it was a known 1. In this case, it's a 2. In this case, it was an m plus 5. So that's a nice property that's stated right here as well.